Okay. All right, so we're going to continue from yesterday. Okay, so let's go over pH once again. Okay, so the pH is the negative log of the hydrogen ion concentration. Now you should get used to your calculator because the calculators differ in how you implement your log function. And we're using a common base 10 log as opposed to a base E log. They're called the natural log. So pH is based on the common log, and it's used, as I mentioned yesterday, it's used a lot in biological systems, or because the concentrations of stuff in our body are so small. If you look on your prescription, they'll say micrograms. That's a millionth of a gram. Frequently, it's in milligrams, which is a thousandth of a gram. And a gram is just 1 gram isn't very much. You're talking about a millionth of a gram. It's pretty darn small. Okay, so and this is what I usually do when I calculate on my calculator. I just do the log and then I negate it, whatever the value is. So okay, so I just did the log of 5.6. And that gave me an answer of negative 1.13. Now it's the negative log, so the answer to this is 1.13. Oh, wait a minute. One small correction. 11.3. Okay, now, we already mentioned that water is both a base and an acid at the same time. These are both very, very small values, extremely weak, but it is an acid and a base. Okay, so the pH for this reaction is 7. So sometimes I'll ask you to convert the pH into molarity. So that's going to be, remember I said logarithm is a fancy word for exponent. So that means if it's a log 7, that's the exponent. And in the case of pH, it's the negative exponent. And that's moles per liter. Okay, there's another p-value that you've probably not heard of. And that is the OH. So the definition of POH is the negative log of the hydroxyl ion concentration. Now, pH and pOH are related and interconvertible. So pOH plus pH equals 14. And I get this from, if it's neutral, pH is 7, and because it's a one-to-one relationship here, that means whatever pH, pOH is the same. This is at neutrality only, and this is where they get the 14. Now, the only time you're gonna run into pOH is in a chemistry class. You know, if you're adjusting the acidity of your spa or pool, you're talking about pH, none of this pOH stuff. However, you're gonna run into it when you're dealing with a basic or an alkaline problem. For example, if I have I have 5 grams of sodium hydroxide, strong base, and 3.0 liters of water. What is the pH? Okay, so let's do the reaction. Okay, so what's pH again? The negative log of the hydrogen ion concentration. Do you see hydrogen there?
Yeah.
Well, it's tied up with the O. So it's, you only see OH, not H by itself. So we can calculate the pOH, however. Now, once we find the pOH, we can find the pH through 14. Okay, so let's talk about this now. Sodium hydroxide. Sodium is it 22.99? Yeah, it is. Well, the decongestants aren't harming my memory. Taking a whole bunch of decongestants. Okay, so we're gonna go 5 grams. That'll give us moles, all in 3 liters. And this is equal to the hydroxide concentration. Okay, so that's going to be, let's see, divided by 40. Now, this is a balanced equation as written, and the relationship between OH and NaOH is 1-to-1. So if we know the moles of NaOH, we know the moles of OH. Remember, square brackets is moles per liter. So Okay, so what is the POH then? We need to take the negative log of 4.2 times 10 to the minus 2.
Negative log, the OH. Yes.
Okay, so if the POH is 1,4, what is the pH? So depending on what species is there, you're either gonna do pH or POH. If you only have OHs, you're gonna do the POH. If you only have H's, you're gonna do the pH.
I lost you on the negative log. How, what did you put? The negative log of the OA of the QOH we just found?
Yeah, okay, so on this here, I did the negative log of 4.2 times 10 to the minus 2. I got 1.4,
Oh, I also got 1.4.
okay? Well, sounds like you did it right.
Okay, but then you have to subtract it by,
Let's see, we found POH. I want to know the pH.
right, so POH plus pH is 14.
Yeah,
pH
So
7.
14 minus,
So you get 14.
yeah, 14 is the two P's added up. So if you know one, you automatically know the other.
1.26. 12.6.
Yep,
So POH and pH will always be 7.
at neutrality.
Oh.
And because that's true, you can then interconvert between the two.
Yeah.
Did you see your grade, by the way? See, and you were worried. Okay, does that make sense? I put a lot of worksheet under Canvas files, unit 2, practicing pH and so on. Okay, so. Are there any questions about this calculation? Okay, there's a type of reaction that most of you probably have heard of. A neutralization reaction. And that's when an acid
Yep.
plus a base are mixed. One of three things are gonna happen. If the OHs and the H's are exactly equal, then there's none of them left. However, if the H's outnumber the OHs, we're gonna have H's left over. And then vice versa. All right, so let's say we had. You got 6 moles of HCl and a half liter of water and 3 moles of sodium hydroxide in half a liter of water. So now you're gonna have 1 liter of water, 1/2 plus 1/2 is 1. And you're gonna have, remember, these are both strong acids and bases, so they totally disassociate. So that means we have 6 moles of HCl, we have 6 moles of H plus, 3 moles of OH. Because they're strong acids and bases. So over here now we have 6 moles of H's, 3 moles of OH's. What happens when OH and H get together? Right, they neutralize. It forms water. So we've got 3 of OH, 6 of plus. So what do we have in surplus here? Well, the 3 moles of OH and the 3 moles of the 6H form water. What's left over? Wait a minute, let me, so we have 3 moles of H plus left over. This is a classic problem. We have acid and base, dump them together. What's the resulting pH? Or, so if there's H's left over, we're going to calculate pH. If OH's are left over, we're going to calculate pOH. All right, does that make sense?
And what happens to the Na and Cl? Does that formula get?
What happened? What about the Na and the Cl?
Oh, wait, that's false.
Salt. In fact, there's a fancy name for it. It's called a conjugate
Oh,
salt. Yeah. So if it's perfectly H's and O's balanced, all you have left is salt water.
uh-huh.
But if there's extra of one or the other, you're gonna have salt water plus acid plus or plus base, and which is more. Does that make sense?
Yeah.
Cool. All right. Let's do a problem then. Okay, so we've got, and I want to know what the pH is. So we're going to dump them together. So we've got to convert the grams to moles. So that's 1.5 grams. And HCl, the molar mass of HCl is so that'll give us moles of HCl. And this was 40 grams per mole. All over 5 liters total. Okay, everyone okay with that?
On the other account, you put 3 under that for that side and then 2 for the other one. But they're both probably the same, I'm guessing. You could add the liters together.
Yeah, because it's just mostly water. Just gonna add it together.
So would you divide 5 by each one of them? To get the constant.
Eventually, the thing we need to do first is which do you have excess of? So we need to calculate moles of H's, which is the same as moles of HCl. So that's going to be okay. So which we have more of? OHs or H's? How do I find that out? Besides looking at it. How do we calculate which we have more of?
Subtract.
Yeah, subtract. Okay, so we have the OHs and excess, because 7.5 is bigger than 4.1. This is why you needed to be able to do pre-calc in here. Okay, so we've got now, does everyone see why we have more OHs than H's? You have to do the mole calculation first. Then you subtract the two, whatever's more, that's the excess. Now, if you have more OHs, that means we're gonna calculate POH. And more H's, then we're gonna calculate pH. Yeah,
Is it 5.02 liters or is it 5.0 liters? Did you have?
oh, yeah, 5.0.
Okay.
Okay, so let's see what this turns out to be here.
That's fine. What's the one calculating that? So it looks like we're calculating the excess. We have
Yeah.
to find the excess first.
If there is an excess, maybe it's perfect. Normally, it's not. Normally, there's an excess of one or the other.
The access
Did you
gives us
calculate?
the pH, is this the P or is this the? What does this give us when you divide by, after you divide by five?
The concentration of OH,
The column?
because OH is in excess compared to the H's.
Oh, okay.
Okay, so it's 6.8 times 10 to the minus 3 moles per liter. Okay, now that's going to be, because OH is in excess, we're going to calculate POH. So that means we're going to take the negative log of 6.8 times 10 to the minus 3. Well, let's go with sig figs, it's going to be 2.2. Okay, that's not what I asked. I asked for pH. So the pH is going to be equal to 14 minus 2.2. Okay, now this is going to be your take-home problem. Acid-base reaction, you're going to have excess of one or the other, and you're going to calculate both pH and pOH. Okay? But the essence of it is, and we're only working with strong acids, we're only working with acids that give off 1 proton, as opposed to acids that give off 2 and 3 protons. We're only doing 1. To make it as simple as can be. All right, are you guys have any questions about that?
Because that's what it is. I don't need that. Or, um, the-
Along.
Yeah, so. That's what you mean.
So let's do maybe one.
All right, any questions about this guy? All right, why don't you try one on your own here?
6.8.
Again, I want to know pH. We're going to work in 2 sig figs, make things easy here.
You're supposed to put that.
That's like the base.
Okay. Try that problem.
So we need to make sure we go.
Going 7 minus 2.1, is that what you mean? Hmm,
14.
Okay, let's go.
okay.
Don, pick up your tab.
That's fine, that's his one. Sounds for you. We're just really very nice, but I'm not.
Yeah. Is it clear?
Let's see.
35.
You should remember. With 44.6. Twice the way. And then if you. What's your access to 14? What's that? 3.2. Let's put that there.
It's still assumption.
Three, was, 4 and 5. What was it? Total leaders are what?
Actually, it's 0.5. And we H is one H, okay.
Wait, hold on. I got a little copy.
Yeah.
Yes.
Hold on, oh, hold on, I'm not there yet. There.
There's some questions I have to.
There is some practice for you guys.
Which get rid of this.
Isn't it? The checklist. I'm done trying. This is what she said. The acid and base one. And so make it easy.
Good.
So, where did you get it? Is that which the
Hey, look, that's the molar ones.
yeah, so it's
Look at what's pretty easy. So you always have to turn in the molar stuff to calculate, that's my idea, right? So this is so simple. It's this, and then right just. You say everything done? You know,
It's so
just
easy.
for each one. Is it easy?
No,
What is?
it's
Small.
Yes. Excess. Yes, this was, and then I divide it.
Yeah, well, you do divide, because you're processing draft and make it simple, right? But then also, this is kind of hard. That's in the regular form, not flat simple. Anyways, and then, you know, same thing though, the same thing, you can still wait it, because you just transfer that. Anyways, you want to get the distance between these two. And you use that, and you divide it by the total water.
Yes.
Professor, we have a question. Professor. And then you take this, and clean the difference, which you want to put it right, and that's the excess. You understand that excess, right, because these points cancel out. Cancels. Divide by your 4, is the amount of volume. And you just divide by the rest of the wall. Once this into a law. This number. And 14 minus that, because this is the POH. Yeah.
Total here. Your bill, and expensive, then just.
let's follow along.
This is 2.08. So if we're doing 56.
All right. As normal, convert to moles. So let's do this. So sodium hydroxide.
Yes, 2 bar, right? I think it's round here. I'm pretty sure about mine's 2.8.
It's close enough.
It's close, I think it's rounded correctly somewhere. That's the right step. Because I wanted to.
Here's the ball, and then probably did it somehow. I gotta remove both sides. Okay.
Sometimes we forgot.
It does, but it's like a time. I was like, learning how to use it, but not wait, my own scientific exploded, I'm violent. Well, we're not allowed to use the phone service. It's like, okay, first calculator. Oh.
Okay, so first step is convert to moles. Then find out which you. Okay, so we're gonna do 3.6 divided by the molar mass for sodium hydroxide gives you 9 times 10 to the minus 2 moles. Doing the same thing for HCl, we've got 4.9 times 10 to the minus 2 moles. Okay, that means we have more OHs than H's. That means we're gonna end up calculating the POH and then converting that to pH. Okay, so we've got all that. In 5 liters.
Question about subtraction. I don't want to do it by hand.
Okay, what now?
I have this weird question.
You first gotta find moles of each one.
I got that. I'm talking about what is it, the arithmetic of knowing what to subtract, because a negative's not throwing me off. So like, I just get the bigger number subtracted by the smaller number.
But you gotta make sure, now this is a scientific notation.
Scientific notation.
Okay, this is an important point he's bringing up. And if you're adding or subtracting scientific notation, you have to make sure the exponent is the same on both. Which is where your question was going, right?
That too.
Okay, in this case, if you kept it at -2 for both of them. Subtracted, and then it's 4.1 times 10 to the minus 2. Okay, now you have to make it the same. You cannot subtract unless they're the same. No exception. Okay, one's a -3, one's a -2, convert one to the other, doesn't matter which one. Gotta convert. This is so happens it's nicely the same already, but if it wasn't, you'd have that extra step, to convert one to the other.
From the exam, are we converting to not to from the exponents? Please give us an example, we are.
All right, she wants an example. Let's do an example. Okay, so let's subtract those two. Because one's a -3, one's a -2, you cannot subtract them. You have to convert one to the other. So let's convert them both to -2.
Convert them to negative.
Okay, so
It's gonna happen.
okay, does that work? No, does not work.
Is it five?
If we change one, we gotta change the other in the opposite way.
Is it 51?
So, when we go from -3 to -2, are we making the number bigger or smaller?
Bigger.
Making it -2 to -3, excuse me, -3 to -2. So the -3 number is getting bigger, right? So we go from -3 to -2. That number is getting bigger. So that means the other number has to get smaller by the same amount. It's getting bigger by 10. So the other one's got to get smaller by 10.
0.5?
Yes, 0.51.
Point. That turned into -3? Does that turn? No.
-2 means we go over 2 places, -3, we go over 3 places.
Mhm.
So if we go from a -3 to a -2, that means we're multiplying that by 10.
Wait, but when you put 0.51, that turns that one to times 10 to the -3, right? That turns it, you turned it to negative, so you could subtract. Is that the idea?
Okay, so what we end up with is
Yeah.
now we can subtract. We couldn't subtract until both the exponents are the same. You could have done -3. Let's do it to -3. It really doesn't matter. So we want to end up with well, it's already in -3. So let's do the other one. We want to do the okay, so 5.1. I'm going to convert the other one now, 4.2 to -3. Okay, so when we go -2 to -3, are we making it bigger or smaller? We're making it smaller. Okay. That means we have to make the 4.2 bigger to compensate by one place. So that means that's 42 times 10 to the -3.
42. You were 42, right?
Yeah.
Oh,
Yeah.
Bottom line is they've got to be the same. It doesn't matter which one you convert. Got to be the same.
Okay. Hold on. Move it over.
If the number becomes more positive, the other one you have to make more negative. Because we don't want to change the value of the number, we're just changing its mask, so to speak.
Because they have to move it back 3 times to get back to the original number. Okay.
All right, is everyone okay with this process?
Because previous problem.
Yeah,
This is
even
what's
though-
happening. This is what's happening.
Sorry, what?
Coming from the line. Walk left, sitting the lines. So you're going down. So then this one, you bring forward to compensate. I knew they were doing it, they're equivalent, they're just trying to make it equivalent. You see, Isabella would already know that. That's why she's been here.
All right, well, let's go on.
That's okay.
Okay, so now we're gonna take the mold. Everyone, Now we're gonna take the 4.1 mole over 5 liters to find the concentration, because pH or POH is concentration, is moles per liter. Okay, so that means we're gonna divide 4.1 times 10 to the minus 2 by 5.
Now, is it 5.4? Because I added 3.6, the waters together.
5.0. This is 2 and 3. Two and 3. Okay, so that is. Okay, 8.2 times 10 to the minus 3 moles per liter. Now we're going to take the negative log of 8.2. Okay, so the POH is 208. pH is 14 minus 208.
Yeah, it's just not.
Now this has got infinite. The number 14 has infinite decimal places. So when you're subtracting, you need to look at the 0.08. It's got to have 2 decimal places. So that's the pH, 1192. Yeah. As you go, the problem is, when do you round? Theoretically, you're supposed to round at the end. But sometimes the numbers are this long, so you gotta be reasonable.
Or we do log of 8.2 times 10. And then forest with 2.08, why didn't you do 3.1 instead of?
Cause it's two significant figures, right?
Oh, you could have, yeah.
Still gives you the same answer.
Either one's fine. The main thing I'm looking for here is the setup and the concept.
So 11.
Yeah. You make an argument, it's 11.9. Looking at sig fig wise, it's more accurate. Okay. So you're gonna have a take home problem. If I remember, I'll put it up tonight. You'll have weeks to do it.
But it's not personal, I said it's.
Okay, now. Backing up a little bit. pH of your stomach is 2. What's the concentration of the hydrochloric acid in your stomach?
The concentration.
I told you pH is 2. It's 10 to the minus 2 moles per liter.
Well, there should be 6.4. There should be. There should be 6.
Okay, so log of the next part, but it's the negative of the exponent. So 2 is 10 to the 2 negative moles per liter. Now, you might ask yourself, how strong is stomach acid? I have shown from personal experience that stomach acid will take pain off the heart.
I know that's it.
You ever wonder how I figured that out? Yes. I was in the
Oh, no, that's what.
Well, while your time, we got, being on cars really well. So keep that in mind, or if you want to take paint on your car, drink too much.
Oh.
Okay, that's what I wanted to cover today. So that's it on that. Tomorrow we're going into free energy, which is what our dry lab is.
We got those with them.
I'm left-handed, but metals was here.
That's right, you didn't do the metals correctly, it's all of this,
You can't just ask her.
so you left this off. Now, remember I said, you're probably not gonna have to do correction. You didn't believe me, after I looked at your test. Oh. Mhm.
Oh, I got four. I have it. So you can't answer the other thing.
This makes sense.
Yeah.
And certified.
But I know the practice has so much.
So.
And video tonight.
I will be watching the video. It is very. Probably so. I think this.
This is also safe again. Thank you. Should I?
But.
Thank you.
No.
Yeah.
So nicely.
This is a practice difference, because that's what. What's left is the difference between these two, you divide by the liters of water that it has. Okay, so you get the difference. And plug it into a log, get the POA. And plug it into a log. Okay, that number is the difference. Well, it's 14 minus 4, chance from 5. The only, the team. Weird. What is? No, is the question if you add these together. 11.92 is the what, into the solution? Of the. No, but it's the future, this whole solution. The entire solution. Yeah. That's the formula. No, that is, yes, it is. What yeah, pH equals.
47 is the best of the thing like
EOH plus pH equals 14 for neutral. For neutral, this is a formula, well, that's why 14. That's why you subtract 14. By the EOH, so you get the code.
So first step for me is.
You were writing things more down on this.
No, no, my.
You did that right. You don't do it. I don't think anything until. On something I don't have to write down. Yeah, I don't.
We don't make part of, like, big, for example,
Yeah,